Hey friends, my name is Z and you're watching MakesItEasy, and welcome to a new video for IGCSE at Math 10 today. We have rules and examples for functions, and we'll look into questions for functions next lesson, but anyways, here's the rules and examples starting with some basics. But before we get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And anyways, here's some key terms to note. So basically, a function is basically denoted as f of x, or like represented as f of x, or basically it equals to y. Basically, f of x is the same as y. So domain is the set of possible inputs for a function, and basically domain is the values for x, and the range is the set of possible outputs for y, or f of x here. And then we have what's not a function and what is a function. So first we have one-to-one mapping. It is a function, and one-to-one mapping could be like a straight line where one x value maps to one y value, and vice versa. Number two, many-to-one mapping. It is a function, and many-to-one mapping is basically where one y value may be mapped to two x values. Like we have this quadratic graph right here. Y equals 0. Which is right here, it may be mapped to two x values, like so, and it is a function. And many-to-one mapping, however, is not a function, and many-to-one mapping could be something like this. Looks like this graph right here, where one x value may be mapped to two y values. And if you draw like this green line right here, you can see that one x value is mapped to two y values, which is not a function. So for example, when we try to find the domain or range for a function, a suitable domain could be like x is like x and like an e and r, like this, like so. So basically what it means, let me just write it properly, like this. Basically it means that x is any amount of real number, so it could be any real number. Like x is like any real number, and the range could be like y is bigger than or equal to 0, or fx, they are the same thing, or it could be like y is less than 1, y bigger than 2, so on, so on. Then we have some more basics. We have image. An image is basically a set of all output values a function may produce. So when we have this function g of x right here, and if we set x as a, so if this is a, the output would be 2a. Therefore, it means that the image of a is 2a. See how they relate? A, and the output is 2a. Then we have this notation right here, like how to say it. F of x equals like 2x squared plus 1. The correct way to say it in like mathematical terms is f is such that x is mapped to 2x squared plus 1. And then we have some more like complex function, like composite function. We have f of x, basically it's like stacked up. You can stack the f together to get f squared x. And when we have another composite function, f of g of x, like this, you can't just square the f because there's no 2f, and you can't square the g because there's no 2g. What this means is that the x value, so like this is normally the f of x function. When you have the g of x right here, the g of x is basically the value of the x. So what I mean is that when we have f of x equal x squared and g of x equals x cubed, when we have f of g of x, we put the g of x into the f of x, the x value. Therefore, it will be something like x squared, so x cubed squared. So look at how they relate. G of x is this, and this, and square, like so. Because you're replacing the x value for like the original x value from the f of x as the g value, the g of x value. And moving on, we have some translation for functions. So we have quite a lot here. So number one, when we have a function plus 4, and the plus 4 is on the outside, you shift the function up by 4. And if it's minus 4, you shift the f of x down by 4. And one thing to note is that it's outside the bracket. So if you have like, let's say, x squared plus 1, because it's outside the bracket, it's not like x plus 1 is different. If it's outside the bracket, like so, you shift it up by 1. And if it's outside the bracket, shift it down by 1. It depends on the sign. And then number 2, you have these two, which is like similar to the first two ones. If it's inside the bracket, if it's plus 4, you shift the function to the left by 4. And if it's minus 4, you shift the function to the right by 4. So it could be like x plus 1 square. Basically, you shift the function left by 1. If it's x minus 1 square, you shift the function right by 1. It's kind of like the opposite of the first one, where positive is like on top, like going up for the first one, but positive is going to the right, sorry, to the left for the second one, like this example. Then you have minus f of x, so that minus is on the outside. And let's say you have this function, like a function, x minus 2 square, and the negative sign is on the outside. You reflect the function on the x-axis. So like the x-axis is like this line right here. So when you have like, let's say, this graph, when you put a negative on the outside, it will become this. And the opposite is where the minus is inside the bracket, or like in the x. So it will be like minus x minus 2 square. It will be a reflection on the y-axis. So if it's like, let's say this, it will be this. And then we have 2 more translations to go. So when we have f of x equals 2 cos, like on the outside, 2 cos x, you stretch the cos x or any other trig graphs in the y direction by 2. And if it's cos in the bracket 2x, you stretch the cos x in x direction by 2. And basically the y direction is like y up, down, and x is like this. So when we have an original cos graph, let's just rub this out. An original cos graph is something like, oops, like this, like so, and this 1, and this is 1. When we do, and this is cos x. But if we do 2 cos x, you have to stretch the cos x in the y direction by 2, and it will be something more like geometric. And this will be minus 2, and this will be 2. Oh, this is minus 1. And you can see how they relate. Then we have some inverse function. So basically, inverse function is like you reverse a function, like inverse. So it's basically like this idea. When you have an input, you times by 3 to get an output. But the inverse is that when you use the output, you divide by 3, which is the inverse operation of the first one. You get the original function. And we have this quick note to know that this sign right here, it means identical, and we'll look more into it in the coming videos. So like f of g in brackets to the power of minus 1 is equal to f of this and g of this. It's like the inverse. So the inverse function is denoted as f and to the power of negative 1 with an x. So this is how to find an inverse function. So first you have a normal function like f of x equals x plus 5 right here. Then you substitute this f of x by x and this x by y. Basically you remain this x right here. So it will be x equals y plus 5. Then you have to make y the subject. In this case you minus both sides by 5 right here to get y equals x minus 5, and this y is a new inverse function right here. When x minus 5, let's just highlight this. Y equals this, and x minus 5 equals this. Then we have some graphs for inverse function. So the idea of inverse function and normal function is that, let's say this is a normal function, right? This is a normal function, f of x, and this is an inverse function of f of x. So the normal function is denoted as the red line, and the inverse function is the blue line, and the dotted line right in the middle is the line x equals y or y equals x. So what an inverse function is that the inverse function reflects the function from the line y equals x. So basically the inverse function is a reflection of the original function on the line y equals x. And they always cross in the point that lies on y equals x. In this case, it's this point right here. Because if you like equate them two, you can find the intersection point. In this case, there's only one intersection point. And all inverse function and its non-inverse function, like the normal function, they like intersect on the point on y equals x. And then we have modulus function. So we have modulus basically means the absolute function, the absolute value. And we'll look more into it later. Absolute value. So modulus basically denotes as like this, like two straight lines with a number in the middle, like so. So basically what it is that modulus function, the number inside the modulus like symbol, you have to make it into positive. So like let's say you have this modulus -1 or the absolute value of -1, it will be 1 because you have to not use the negative, you have to use the positive value. And this, if you have like modulus of -1, 2, 3, 1, 2, 3, like 1, 2, 3, it'll still be 1, 2, 3, 1, 2, 3 without the negative value, symbol. And one thing to note is that if you have like this like modulus function, like modulus symbol around a y value of or like f of x, then if that equals 0 or like equals a, then f of x equals a and f of x equals -a. Because there's two scenarios here. So if we have this, there are two scenarios. You can either have y equals a, where you just like get rid of this modulus sign, or y equals -a, where you times everything by negative. Or like times both like one side by negative and get rid of the modulus symbol. So as I said, we have a modulus graph right here. The idea of a modulus graph is where there's no negative value, when there's no like negative sign. So basically all outputs are positive. So we have this graph of f of x equals the modulus, like the absolute value of x. As you can see, if it's a normal f of x equals, if it's like a normal f of x equals x graph, it will be a straight line like this. Oops, like this. But now that's the absolute value, so it will be like this. It's basically a reflection on the x-axis for the one in the negative region. Because it's supposed to be like this, then you flip on the x-axis to become this. Then we have some more examples graph for modulus function. We have f of x equals the absolute value of sine x. It's supposed to be like this, and basically you reflect the negative part by the x-axis to get something like this, and get rid of the bottom part. Oops, yeah, but you know what I mean. Like, becomes like a hopping bunny, something. And then here we have f of x equals 1 minus x squared, the absolute value. So it's supposed to be something like this, 1. And it's basically related to translation too. As you can see, it's a negative graph because it's a negative quadratic because it's minus x squared. And the plus 1 is outside the bracket. So you have to shift the minus x squared graph up by 1. So it'll be something like this. Then you put the modulus to reflect the negative part to the positive. So it'll be like this, which is basically what this is. And then we have f of x equals the absolute value of cos x, as I mentioned. And here we have some f of x equals the absolute value of tan x, which are basically trig graphs, and we'll look into it more in the coming videos. Then we have some examples. Find a suitable domain and range for 2 cos x. So we know that the cos x graph looks something like this. And when you have a question that asks you for the domain and range, you draw a graph because it's more straightforward. Draw a graph. Draw a graph like so. So when you have this 2, basically it means that you're stretching the cos x graph on the y direction by 2. So instead of 1 and minus 1, it'll be 2 and minus 2. And as you can see, the domain or the x value, it could be anything because the x is not restricted, it could be like any real number. So x could be any real number. So it could be something, you can write something like this, or you can just write x is this, any real number. It's the same thing. And the range, I'll use f of x. F of x could be it could not be anything, because if you can't be 3 or minus 3, or you can't be anything beyond 2. But it can be 2, because if as you can see, the range is like the output or the y values can be above 2 and can be below minus 2, because there's no x value for that. So f of x could be, it has to be between minus 2 and 2. So it'd be minus 2 smaller than or equal to f of x smaller than or equal to 2. And these are the answers. Like so. And then we have find the suitable domain and range for f of x equals 2 to the power of x. So we just write some domain. You can think of it logically. I'll just write it in a short form. Just think to yourself, is there any x value that are not like can be mapped onto this function right here? And all values of x can be mapped, so x can be anything. Because you can do 2 to the power of minus 100, 2 to the power of 100, and it could be anything. Then we have the range. So if you know the graph y equals e to the power of x, this exponential graph, it looks something like this. Like there's an asymptote, which basically means it doesn't touch on the x-axis. Oops. Like so. And this is just like 1. Oops. It doesn't touch the x-axis. So that basically means there's no output for any values of 0 and below, because the range or the y value has to be above 0. And one way to prove it is that if you set this y value by 0 equals 2 to the power of x, to solve for x to find the value of x that maps to the y value of 0, you have to take the log base 2 to both sides, right? So it'll be log base 2, 0 equals x. But there's no value, and this is incorrect, because it's like an error. There's no like log base 2, 0, because 0 can't like exist in the bracket most of the times. So the f of x value has to be bigger than 0. It can't be equal to 0, as shown here. And these are the values. Then we have some questions. When we have f of x equals 3x plus 1 and g of x equals x squared, find fg with a 5. So there are two ways to approach this. Number one, you could just find the f of g value, like so, find like a function, and then you set this x by 5. But there's another quicker way to do it. So what you do first is that you observe the function, the composite function. This is called composite function. You observe the letter of, or like the function that is closest to the number. In this case, it's g of x, because it's like g of 5. So what you do is that you set 5 in the value for g of x first. So first you do at g this, so it'll be 5 squared, because you're setting the x value as 5. Like so. And x, and this will be 25. So now you know that this value, like g of x when x equals 5 equals 25, you can substitute it back into the function. So f of g of 5 will be equal to f of 25. And let's just put it into the f of x function. So it'll be 3, and the x value is 25 here, so it's 25 plus 1. And 3 times 25 will be 75, 75 plus 1 is 76. Right here. And now you have another question. F of x equals 2x plus 1, find f squared x, which basically means there's 2f. So this f squared x is basically f(x). So let's just put f of x into the f of x of the x value. So it will be 2. The x value will be the f of x function, which is basically 2x plus 1 plus 1. And you can see this is basically an f of x function, where this x value is basically another f of x. basically an f of x inside an f of x. So if you expand this out, it will be 2 times 2x equals 4x. 2 times 1 is 2, 2 plus 1 is 3, so it will be 4x plus 3. And then we have some more functions examples. We have f of x equals 2x plus 1 over 3. Calculate the inverse of f and then like f of x and find this value. So first let's do the inverse. F of x equals 2x plus 1 over 3. You set the f of x by x and 2y plus 1 over 3. You make y the subject, like so, and 3x minus 1 over 2 equals y. And this is y the subject. So this you have the inverse function. Just drop this out. So it's f inverse equals 3x plus 1 over 2. So you have to set this x value by 4. So it'll be this 4, and then 3, 4 minus 1 over 2. And if you expand this out, 3 times 4 is 12, and 12 minus 1 is 11. 11 over 2 will just be 11 over 2. So the final answer is 11 over 2. Then we have f of x equals 5 minus 2x and g of x equals x minus 1 over x plus 1. Find gf and inverse. So know that from just now, gf, this is right up here, gf inverse basically means g inverse f inverse. So the f inverse value is in the g inverse value of the x value. So let's just find the inverse of f of x. So it'll be x equals 5 minus 2y. So 2y equals 5 minus x, and y equals 5 minus x over 2. So basically the inverse of f of x is 5 minus x over 2. So f inverse equals 5 minus x over 2, number 1. And number 2, find the inverse of g of x. So it will be x equals y minus 1 over y plus 1. Just times everything out by y plus 1, it will be xy plus x equals y minus 1. Minus both sides by y and plus both sides by x. So it will be, or actually you can minus both sides by xy and plus both sides by 1, like this. Y minus xy. You factor out the y on the right hand side. y minus x equals x plus 1. And basically you just divide both sides by 1 minus x to find y, so like make y the subject, which basically means the inverse of g is x plus 1 over 1 minus x. And then what you have, when you have these two inverse functions already, f inverse and g inverse, you're trying to put f inverse into g inverse. So f inverse g inverse, so g inverse f inverse, you put f inverse into g inverse, and it will be a long function, like a long fraction. It will be 5 minus x over 2 plus 1 over 1 minus 5 minus x over 2. And you have to make everything into a single fraction. And I'll just rub this top out. And let's just solve the top first. Number 1, it will be 5 minus x over 2 plus 2 over 2. And then it will be 5 plus 2 is 7. So it will be 7 minus x over 2. And the bottom is, let's set it as 2. Bottom 2, 1 minus 5 minus x over 2. The 1 can be rewritten as 2 over 2. So 2 over 2. So 2 minus 5 is minus 5 plus 2, which is minus 3. Plus x. Because it's minus x, so it will be plus x. So it will be x minus 3 over 2. And let's just rewrite this. And then when we have what 1 and 2 is, basically it's that g inverse f inverse equals 1 divided by 2, which basically means it's like 1 divided by 2 or 1 times 1 over 2, or 2. And as we know, 2 is a fraction, and when you have something over a fraction and the fraction is in the denominator, we can flip the fraction over so that the denominator is now a numerator in a fraction. So what I mean is that as we have this, like something over 2, something like 1 over x minus 3 over 2, we can flip this fraction to become 2 over x minus 3. As you can see, if you do like 1 over 2, it'll be this. And then the 1 will remain as 7 minus x over 2. And now you have to times both sides, and you can cross multiply first by crossing 2 out of each, and then you're left with 7 minus x, and then x minus 3 is at 1 over x minus 3, so you just times everything to get 7 minus x equals x minus 3. And that's it. And this is basically GF inverse. And it's quite a complicated one, so if you don't understand anything, just let me know in the comment section and I'll reply to them. And then we have some more examples. Calculate the value of f of minus 1. So it'll be f minus 1 equals 3 minus 1 minus 2. Minus 1 times 3 is minus 3. Minus 3 minus 2 is minus 5. So let's just check it in the calculator, and it's minus 5. So it'll be the absolute value of minus 5. And as I said just now, when you have the absolute value of something, you have to get rid of the negative sign to only look at the positive one. But positive value, so it will be 5. Get rid of the negative sign. And then we have f of x for like this. Find the values of x, which f of x equals 8. So basically you set this f of x, like the function, equals 8. Let's just highlight this, like so. So there will be two scenarios. There will be 3x minus 2 equals 8, and 3x minus 2 equals minus 8. Like a minus and a not minus. So then this will be 3x equals 10. And this will be 3x equals minus 6. Oops, minus 6. So if you find x, it will be two values. Number one, x will be 10 over 3. And x will be minus 6 divided by 2, it will be minus 2. And then lastly, we have to find the intersection point or point of these two functions. So when we have two modulus graph, just don't panic, it will be the same way. So it will be 2x minus 1, you equate both equations. You will have two scenarios as well. Number one, it will be 2x minus 1 equals x plus 2. Or number two, you times either one side by a negative, and I'll just do the right side by negative. So it'll be minus x minus 2, like so. Basically you just solve for x, it will be x equals 2 plus 1, it will be 3. And then to plus both sides by x for the second one, it will be 3x equals minus 1. And in this case, you can find x easily by saying x is 3 and x is negative 1 over 3. So when you have the intersection points already, when you have x and x, you have to find the intersection point, which is you have to find the y value corresponding to this x value. So just find a function that's much easier to find the y value. In this case, it's this one. So f of x, or basically the y value, x plus 2. Let's put the first scenario where x is 3. So it'll be 3 plus 2, which is 5. The first scenario. And then the second scenario where x is minus 1 over 3. Minus 1 over 3 plus 2. If you put it into a calculator, minus 1 over 3 plus 2, you get a function of 5 over 3. So that's the corresponding y value. So now we have two sets of coordinates. Just write it here. That basically means it has two intersection points. When x is 3, y is 5. And when x is minus 1 over 3, y is 5 over 3. And these are the final answers. And that's it for this rules and examples video for functions, where today we look into lots of different functions like composite functions, normal functions, inverse functions, and modulus functions, and so on. And if you enjoyed this video and found it useful, please leave a like and subscribe, and ring the notification bell so you don't miss out on any future videos. And if you have any comments or constructive feedbacks or any confusion about this video or any examples, just drop that in the comment section and I'll reply to them. And check out my social media in the description, for example LinkedIn or Instagram. Or if you need any learning resources or teaching resources, just check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be questions for functions. And until then, stay safe and happy learning.